computer. All right. So yesterday we talked about inheritance. When you think about, or can anybody explain inheritance?
Mama, daddy, and children.
All right. Yep. Mommy, daddy, you're inheriting from, your parents, grandparents, etc. Let's see. I'm gonna actually write some code. So what are we doing? So there's inheritance. That's a type of programming where classes inherit attributes and methods from other classes. We also have one, it's called composition, and that's what we're gonna talk about today. So I'm gonna cd, I'll just make directory. Let me zoom in a little bit. Composition. And then here, I'm gonna just touch examples, .py code. All right. So we're just going to do a quick review of inheritance and then talk about composition and how they kind of relate to one another, or essentially the differences. So if I'm building an animal or a dog, so I'm going to create a class animal, and this animal class has a diet and a weight. So it can be an omnivore, herbivore, carnivore. That's what I'm thinking right there. Self.diet equals diet, and then self.weight. Wait. All right. So what's one? So we have an animal. What's one level deeper that we can get a little more specific into an animal? I'm thinking like of a mammal. So we have mammals now. And a mammal is a type of animal. So if I wanted to create a mammal class that inherits from the animal class, and the only thing that the mammal class is whether or not it's a primate. So this mammal, I'm spelling mammal wrong. The mammal class inherits attributes from the animal class. So we have the diet and the weight. Chris, how do I pass the diet and the weight attribute to the animal class?
Use super.
So super. So the super method just looks at what is the parent of the mammal class, and that is animal. So do the dunder init, and I can pass in diet and weight. And then is primate, I can just do self.is primate equals is primate. And that's the only attributes that's specific to the mammal, I guess, mammal class. These other ones, the diet, weight, is still specific to the mammal class, but it inherits those instance variables from the animal. So if the relationship between mammal and animal, how would you describe that relationship?
I guess the animal would be the parent.
Okay.
Or the class
Subclass.
But so a mammal, what I'm thinking is a mammal is an animal. Does that make sense? So a mammal is a type of animal. So we can say like a mammal is an animal. So when we think about inheritance, it is a relationship. So a mammal, why do I keep doing it? A mammal is an animal. And we can get into a little more specifics too. So I'm going to create a dog class. A dog is a type of mammal. And def dunder init, And I need to think, which we have. Let's have like a name. So self.name, the breed of the dog, and we can pass in is primate. And then also diet and weight. So this is where we have like a parent and a grandparent. So we're multiple inheritances here. And we can say, all right, super. Oh, forgot to add that colon. So super dot dunder init, dunder init, and then we can pass in is primate, diet, and weight. And the last one, self.name equals name, and self.breed equals breed. So this is inheritance. So it is a relationship. So a dog is a mammal. So this is where inheritance is inheritance is a relationship. So dog is a mammal, mammal is an animal, and I guess the animal is the most parent class. And mammal is a subclass of animal, and dog is a subclass of mammal. So if you hear the term subclass essentially just means like the child, but the correct terminology is that it's a subclass. All right. Any questions on that from a inheritance? All right. So if I wanted to create a dog, so we just filled out, my wife and I just filled out a form to rescue from this golden retriever rescue in Chicago. I think it's called As Good as Gold or whatever. And we're about to adopt a golden, and my wife wants to name her Lucy, and the breed is a golden retriever. Is it a primate? Was it false? It is not a primate. The diet is, I guess it could say primarily carnivore, but I think they can also be an omnivore. And weight is just like 60 pounds. So if I want to print Lucy, I can go ahead and do that. I can clear. I can do Python composition example. So, and now I can actually grab all the attributes. So if I wanted to see, let's just like print all the attributes. So str method, if I want to make this a little easier to see. So instead of Lucy showing up as a dog object, I want it to actually print kind of nice. So I can return like an F string. And I can say like breed, self.breed. Name. Is primate, diet, weight. So is primate, diet, weight, So if I did that again, clear. I did that, I can see I still have, is primate, primarily carnivore, 60 pounds. So the type of relationship this is a relationship. So a dog is a mammal, mammal is an animal, etc. Any questions about the review of inheritance? All right. So let's talk about, instead of inheritance, let's talk about composition. So inheritance is a relationship, whereas composition has a relationship. So what are some attributes that are unique to a dog? Such as like
Barking.
barking. Okay. So barking, so dogs can bark. But let's go with physical attributes. Like most dogs have fur. That's what I'm thinking. Does anybody else have anything else? Like tail, I guess, as well.
Pause.
Paws. So yeah, we can do all of that. We can create classes for paws. Whoop. And def dunder init. And what can we say about the paws? We can, what are some attributes specific to paws?
Color?
The color of the pad, like, oh, I guess we can do like color.
Dew claw or not dew claw?
I don't even know how to spell dew claw. Does anybody know? Is it like
DE claw.
D claw? Is
Close
it D
enough.
claw or is it dew claw?
Oh,
So dew claw is that little like claw that comes out like, yeah, dew claw. Let's see. Well, I'm just Googling it. What is it called? All right, yeah. So it's actually, yeah, dew claw. Has dew claw. We can say like pad. I think that's good. Just so def or self dot color equals color, and self dot has dew claw. Whoop. Should I copy that over? When in doubt, copy things so you don't make mistakes. So it might be when you're describing it like classes and you're like, oh, well, a dog can inherit, the paw class, but a dog is not a paw. A dog has a paw. So when it comes to composition, we can, so since it has a relationship, a dog has a paw. So how do we actually write that in the code? Essentially, composition adds those classes like paws, I guess it would be paw, to it adds the classes as attributes to the dog class. So if I wanted to add the color, I'll actually say paw color just to get things a little more specific. So when I create a dog, I can say paw color has dew claw. And now down here, I can say self dot paws equals paw, and then pass in the paw color and the has dew claw. So if you see when I create an instance, a dog instance, I pass in the paw color, whether or not it has a dew claw, which is a Boolean value. And then in my instance variables, I have a self.paws, and I create a new instance of a paw. Paw color and has dew claw. I'm passing that through down here. And down here, I can say color red and has dew claw true. So down here, now I can say pause right here. I can say self.pause in this dunder string method inside of the dog class. So if I clear this, I wonder if I'm going to get an error. Let's see. No. So everything still works. I've got the dog name is Lucy. Breed is golden retriever. Is primate false. Diet primarily carnivore. Weight 60. And then red and true are passed down to here, create a new paw instance. When I do self.pause, I've got this paw object. So, but I can't see any of the attributes of the paws. So if I wanted to access the paws, I can do self.pause like this as well. So if I clear that and run that, I get that paw object because Lucy.pause, I'm doing Lucy, and pause is an instance variable that is this paw object. So if I wanted to grab the color, I can do Lucy.pause.paw color. Now, if I run that, I can see the paw color is red. I can also say has dew claw. If I run that, I get true.
So if you add a string method in your paw class, would that
Yep. So now I'm doing the dunder string method in here inside the paw class, and I could say like paw color self.paw color, and then has dew claw. Is that how you say? Yeah, dew claw. Self.has dew claw. But now, so if I do that, now when I just go ahead and print Lucy, that entire dog object, I get name Lucy, golden retriever. And now down here, it's really nicely formatted to say paw color red, has dew claw true. But what if I had like a method in here, def print attributes, which pretty much does the same thing as a string method, but this is a instance method. So I can say return f string. I'll actually just do the same thing up here, like so. I would say I'm actually going to say instance method colon and paw object. I'm actually going to just do like so, and then do paw color has dew claw like so. So if I clear that and do the same thing, nothing has changed. But if I wanted to access this print attributes, how would I, this print attributes instance method, how would I go about calling this instance method from the Lucy object, which is a dog object? So if I want to do the print attributes, how would I get to this method?
You have to call the instance of the paw.
So I've got Lucy. How do I, okay, so tell me how about, what should I type? You're driving now.
I'm thinking maybe Lucy.paw.method name.
Dot method name, so print attributes.
Oh,
Like
I think it would be the class name, not. Yeah, that looks like it might work.
So I'm calling Lucy, which is that dog instance, and I'm accessing the self.pause, which is a paw instance. So self.pause is a paw instance, And now in order to access the instance methods off of that paw instance, I can just run print attributes and invoke it just like a method. If I run that. So instance method in paw object, and there it is. What questions do you have about that? I can do one more example, but instead of using animal, mammal, etc., I'm just going to do purely composition. So I'm going to create a class, a robot. And this class robot has a few attributes. It has a head, a body, and some legs. And so self.head, head, self.body, self.legs, body, legs. Now I'm going to create 3 different classes for head, body, and legs. So class.body and def under init self dot, I'll just say like the size of the body, like small, medium, large, something simple. Self dot size equals size. And that's it for right that. Next, I can do class body. What is, oh, sorry, class legs. So legs or leg self dot number of legs. So we can create all kinds of robots. We have 4-legged robots, 8-legged robots, 2-legged robots. Self dot num of legs equals number of legs. Should close these up just to make it a little bit easier to read. Oh, give us some space. And the last one was head. So class head. Def under init self. I'll say type of head. I don't even know. Self type of head equals type of head. So here I can do a couple of things. I can either create a instance of a head. So I can say like head 1 equals head and the type of head. What kind of type of a head of a robot should I create? Anybody have any ideas?
Square.
Square. All right. And I can do like leg 1 equals leg, number of legs. I'll just do, 4 legs. And then body 1 equals body and just say like huge. And now if I wanted to create a instance of a robot, I can pass. So like robot 1 equals robot, and I'm passing head, body, legs. So I can pass in head 1, body 1, and leg 1 into this robot. So if I print robot underscore 1, and so let's actually just run that clear. So I've got a robot object, and if I wanted to print the body of that robot, now it's a body object. Likewise with legs and head. So legs, plural. So if I did that, I've got body, head, leg objects. Or like I did up here, where I create an instance of the paw with directly in the as an instance variable. I can do the same thing here instead of passing it in as a instead of passing each instance as an argument into the robot object, like I'm doing here, I can say like head type, body type, and num of legs. And then here I can do head, head type, body type, and leg, num of legs. If I did that here, instead of doing head 1, I just pass in square, number of legs is 4, and body type or is huge, is its size, body size, like so. If I did that same thing, I can comment that out or delete that. Clear. Everything's the same. Body is an instance of a head, or I'm sorry, body is an instance of a body, head is an instance of a head, and legs is an instance of a leg. So these are has a relationship. So robot has a head, robot, not rabbit. Robot has a body, and robot has a legs. So again, the difference is with composition, it's a has a relationship, and you just invoke the instance of whatever object within the dunder and knit typically. And in order to invoke def display head type, return head type self.type of head. In order for me to display this type of head, I have to call display type of head off of this head instance inside of the robot instance. If I want to do that, I can see type of head square. So that's the difference between inheritance and composition. What questions do you have about composition?
I'm trying to think of the advantages of composition over inheritance.
It just depends on, there isn't necessarily an advantage or disadvantage. It's just a different way to architect your program. So there is a specific use case when you want to use composition versus inheritance. So you can use them in conjunction with one another, just like I'm doing up here with animal, mammal, dog, paw. So in this case, the way this is architected is correct because mammal is an animal, dog is a mammal, but dogs have paws. So I'm using composition here. Position. And that is because dog has a paw. It's not dog, not dog is a paw, or paw is a dog. So you just got to be aware of the relationships between the objects.
I imagine larger teams maintain documentation on how all these classes are meant to fit together.
They should if they got good documentation, but not necessarily. But yeah, typically on an organized team, documentation. Yeah, there'll be documentation. But again, composition, you really won't see it in this course going forward. You could implement it in some of the challenges, but you won't see it pretty much going forward. But just know that there's inheritance, and also there's this other thing called composition.